All right, example number 3 says, really what they want to talk about is the base of 10. So when it comes to logs, if I say log base 10 of x, in math we have a tendency to write the same thing over and over and over again, so we have little simple conventions, all right? Log base 10 can be written as log of x. So whenever you don't see the base there, whenever the base isn't written there, that implies that it's base 10, because we have a decimal system. We count by tens, right? And so that's how we leave it. That's just a convention. It just makes it a little easier for you. Likewise, if you have the natural log of e raised to the x, or of x, sorry, not raised to the x, but log base e of x, that is what we call the natural log. Okay? That's the natural log. So those are 2 shortcuts, but they're all logs. I can plug anything in for the base that I want. But if we have a base of 10, which is what example 3 refers to, and if we have a base of e, we either call it log or natural log. Okay, does that make sense? All right. So now for example number 3, we're going to apply those properties from example number 2. So for example, if I say log of 1, what do I raise 10 to get 1? 0, yeah. So think log 10 equals 1, or log 10 to the 0, right? So that's what I want you guys to think, which equals 1. Does that make sense? Let's do another one. If I say log 10, well, you should think log base 10 of 10, right? But that's really 10 to the first power, right? Why did I write 1 there? Somebody said 1. This should be 0. This should be 1. I'm looking at my notes in the book and I'm making a mistake. So the first one should be 0. Did I say 1 or did I say 0? Right? I said 0, but I wrote down 1. Okay. All right. Is that right?
Yeah.
You sure?
Uh-huh.
Okay. All right, so let's do the next one. You can help me with the next one, okay? If I say log of 1 over 1,000, what should I be thinking? I should be thinking log base 10 of 1 over 1,000. I should be thinking log base 10 of 10 to the negative 3. So it should be negative 3, right? Does that make sense? Now, before I do the next one, I want you guys to remember this. We said that if I had winky face, and I took the square root of winky face, that's really winky face raised to the 1/2. Now, the reason for that is I'm taking the square root, or an index of 2, of winky face raised to the 1/2. Now, where we get that from is that if I want to take, say, the 5th root of 3, well, that's really the same as 3 to the first power, So I could rewrite that as 1 over 5. Now, just so we're clear on some of the terminology, this is the base. So this is the base. This is the power. Okay? And the denominator is what we call the index of the root. So some textbooks will say index, and then sometimes they'll call it the root. Right? And I always like to call it the root because when we pronounce it, we say the 5th root of 3. So just before I do this next one, if I were to say to you the 3rd root of 4 squared, how would you write that? 4 to the 2/3. Okay? All right, good. So now tell me this. What is log Yes.
100 to the negative 5th.
No. It's a good guess. That only works for fractions. Okay? Yeah.
Then it has to be 100 raised to the power of 1/5.
You're half right. Okay? So she's half right. What she's saying is that this right here is equal to, in other words, let me make a little room here. What she's saying is the 5th root of 100 is equal to 100 raised to the 1/5. And she is absolutely correct about that. And that's going to be important. That's how we're going to get our answer. But what I want you to remember is that the log of the 5th root of 100 is really the log base 10 of the 5th root of 100. And she's right. If I say the log of base 10 is 100 raised to the 5th, the only problem is I have a base of 10 and I have 100. That's okay, we're almost there. So I got to figure out how to rewrite that. What do I want this 100 to look like? What do I need to use those properties? Yes?
Do I need to take the square root of 100 now? Get it back to 10 or something?
I think you're thinking the right thing. I think you used the wrong word, right? We know that 100 is 10, or is 10 squared, right? So she's saying, well, if you take the square root of 100, you get 10, which is true. And it's true because it's true, but we want it to be, because we have a base of 10, we want it to be represented in some form or fashion of 10. So now what she's thinking, which is right on the money, is that we have the log base 10 of the 5th root of 10 squared. So what if you see something like this, it doesn't matter where it is. If it's in a fraction, if it's under a square root symbol, or in this case, a 5th root, we want to take that base and write it in the same as the logarithmic base. So since 100 is 10 squared, we want to take that 100 and write it as a base of 10, because that's what the logarithmic base is. So now when I do that, I get something like this. I get the log of base 10 of 10 raised to the 2/5, yeah. Does that make sense? One last thing for example number 3. Now for example number 3, they say, okay, if I have 10 raised to the log of 6x, Well, what you should think is that this is 10 log base 10 of the 6x. And remember that property, if they're the same bases, right? Like if it's 10 times the base, right? Because they're inverses of one another. What happens is our answer is this. Right? Do you remember that property? Now, if you wrote it down on your textbook, you'll notice on those last two examples, Mr. Adams kind of changed them up just a little bit. Any questions on these? Okay, good.